You're welcome once more to our chemistry class. In this class, we're focusing on chemistry practical. Okay, we're still looking at titration experiment. In the previous video, we looked at how to get our table correctly. We looked at the formulas that we need, and in this class, we're looking at a possible question. If you just coming across our video for the first time, please give us a follow, subscribe to the channel, and please like the video. Let's go on. So it says A is a solution of HCl of unknown concentration, not given. And then B is a solution of NaHCO3 containing 2 grams per 250 cm cube. Okay? And the equation of the reaction is HCl plus NaHCO3 to give us NaCl plus H2O plus CO2. Okay, we have all the masses given here. The calculation says calculate concentration of A in mole per dm cube. And take note, we're not giving anything on A here. So how do we get the concentration of A in mole per dm cube? The first thing we do, we'll have to calculate everything about B because we can use B to get A. Okay, so we're told that 2 grams of B dissolved in 250 cm cube. Now take note that mass concentration, okay, mass concentration is amount of B dissolved in 1000 cm cube. Now we can try to get that first. We get that and then we proceed. So we want to get the mass concentration of B. So concentration of B. Okay. So we said that 2 grams are dissolved in 250 cm cube. So just have X gram will dissolve in 1000. Want to get that? And that should give us X gram should be 1000 times 2 divided by what? 250. Now if you divide this through, we'll get 4 here, and 4 times 2 is equal to 8 gram per dm cube. What this means is that the mass concentration of the base used in this practical is 8 gram per dm cube. Okay, I'd like to rub off this answer. Let's also try to get the molar concentration. Now the molar concentration of B, remember, we say we can use mass conc of B in gram per dm cube over molar mass. We already know what the mass concentration is, but what about the molar mass? Now the molar mass, we can calculate that. The molar mass will become that is NaHCO3 equal 23 plus 1 for hydrogen plus 12 for carbon and plus 48 for oxygen. So if we calculate the values, okay, we'll get that will be 24, 12 and 48. So we get 84. So 84 is our molar mass. So from this formula now, we have 8 gram per dm cube divided by what? 84. If we divide this, divided by 84, we'll have 0.095. So 0.095 to 3 decimal place. Take note, we must have our units here. Take note of all these. Okay, 0.095, that's to 3 decimal places, and then mole per dm cube. That's the value. I would like to rub off this, or rub this off. Remember the questions so that we'll have enough space to put down what we want to put down. Concentration of A mole per dm cube, concentration of A in gram per dm cube, volume of CO2 gas evolved by 500 cm cube of B. Those are the 3 questions we have in this part. So we've just gotten the molar concentration of the base. Now let's go ahead to get the molar concentration of the acid. What would we have as the molar concentration of the acid? Now to calculate molar concentration of the acid, we need to state the formula. We need to use formula CAVA over CBVB equal NA over NB. In using this formula, we actually know that we are looking for CA. We know VA is equal to 22.00. We know NA is equal to 1 from the equation. We know CB is equal to 0.095 mole per dm cube. We know NB is equal to 1. We also know VB is equal to 25. Okay, now the first thing we do, this formula is, okay, to state this formula, you have 1 mark for that. Now we have to transpose the formula and make what? CA the subject of the formula. That's also another mark. Okay, don't miss any mark for any reason. Take note, I said we can have 50 marks, or the exacted 5% allocated or allotted for this section. Okay, now let's make CA the subject. CA becomes CB times VB times NA divided by NB times VA. Let's substitute. Substitution is another mark. So you don't just hurry any step, please. So the CB is 0.095 times VB is 25 times NA is 1 divided by NB is 1 times 22.00. Now, let's proceed. We have to solve. So we have 0. We can use the original value we had before. We'll just use 0.095 times 25. That gives us 2.375. Divided by 22.00. Okay, we divide that by 22, and it gives us 0.108. 0.108. That will be mole per dm cube. Okay, that's the 3 decimal places. We have 0.108 mole per dm cube. I hope you're following. All right. So let's go on. We asked to find this here. We have gotten the full marks for that question. Okay, let's go on to looking for the mass concentration of A. I'll rub this off next. Okay, rub this off. And to get the mass concentration of A, remember we have molar concentration equal mass concentration over molar mass. Okay, now the mass concentration we don't know, so it means we can just transpose this. Mass concentration in gram per dm cube is equal to molar concentration times molar mass. I hope you are following. Molar concentration we just got, we said is 0.108 multiplied by molar mass for HCl, that will be 36.5. We can add it up, show the workings for that. So have 0.108 times 36.5. So we got 3.942. That will be in gram per dm cube. Hope you can see that. Then the next question, I'll rub this off too. So just take note of that. The next one now says we should find the volume of carbon dioxide evolved or liberated by 500 cm cube of the base. Alright, so let's try to do that. Now, we have the next one. Volume of carbon dioxide evolved by 500 cm cube of NaHCO3. And take note that 1 mole of NaHCO3 will give us 1 mole of CO2 gas from the equation originally stated. And remember, 1 mole of CO2 gas contains 22.4 dm cube at STP. That should also have been stated here. Okay, now it means that from our calculation, okay, that we have the molar conc as 0.095 for this. Okay, so we can use it here per dm cube. So have 0.095 mole per dm cube give us liberated 22.4 dm cube of CO2. Okay, so now for 500 cm cube, we just divide this value by 2. Okay, so you can put it up somewhere. Okay, 1000 cm cube equal to 0.095 mole per dm cube. 500 cm cube will contain, that will be 0.095 divided by 2. So we got 0.0475. So come over here and we use 0.0475 mole per dm cube will liberate do the math, and then we'll have 22.4 times 0.0475 divided by 0.095. So if we do that, we can have the volume as 11.2 dm cube of carbon dioxide that will be liberated. Okay, so that's how we answer this sample question on titration.